Hello, and welcome to a short mesoscale brain explorer tutorial, or termed MBE. In this quick tutorial, I'll show you how to set up the application and get going straight away to replicate the findings that we have in our paper, the paper that was published on this application. So the seed pixel correlation maps on the right, as well as the accompanying graph that shows activity over time for particular regions of interests, and the connectivity matrix. We'll also use the exact same data, or some of the same data that was used to produce these visualizations. So let's begin. To start, you go to this URL over here. This should be provided in the paper. If you're a Windows user, you'll come to the installation page, and the only thing you have to do is click here, download the zip, unzip it, and then run the exe. And that is all there is to it to set it up. So I will also note that there is also installation instructions for developers if you're interested in having this set up so that you can modify the code. There are quite a few package dependencies. It is a rather large program for what it does. So this will be expanded further. So as you can see in the bottom here, I will eventually include a tutorial that also shows you how to interact with the API and, say, extend the application and add your own things. The tutorial will hopefully be at the level where it's specifically aimed at individuals who are just starting out, with Python. Right. So trying to keep this very simple. Right, that link should take you to the latest version, which right now is 0.5.0. Please note that the 0 at the very beginning does mean that we are in pre-release. So version 1.0.0 will be the release which is no longer a pre-release. So this does mean that we're still in beta and that we still have issues. I will note them as we go along. I've already taken the liberty of downloading the zip file, as you can see here. So this is what gets downloaded. You extract that, you get this dist for distribution folder over here. You open it, you open pipe GUI, and then in pipe GUI you look for your exe. Double click that, and that is all there is to it to run the application. So right now you can ignore the terminal window that appears on the left. This is used for debugging purposes. It is not going to be involved in the final release for the non-beta release of the application. This error warning that appears on the left does not occur when you run the application, say, via PyCharm, so via a developer menu, and I actually have yet to figure out how to get rid of it. You will notice, for instance, that TIFF files load slower in the exe version of this rather than when you're running it, say, via PyCharm as a developer. However, it's not slow to the point that it destroys the functionality of the application. So the very slow over here seems to be overstated. Okay. Anyway, let's get started. So first things first, I will quickly just clean this up. Okay, I deleted the files that were there from the previous project. I could actually also just have done, let's close this, and yeah. Okay, here. Okay, fine. I'm happy with that. So, this is how the application actually should look on first startup. To get started, we have to define a project. So let's make a new project. We'll call it mouse285, just like in the paper. So when you're making a project, it is assumed that here all the data in one particular project has a common origin. So that typically means that it's a common mouse, so you don't want to be importing data into one project if you're doing analysis across mice. Because what you have to actually do if you want to do analysis across mice instead of within a single mice is to shift it so that they're both in the same coordinate frame, and I'll talk later about how that's done. But for now, when you're doing analysis, it's probably a good idea to name your project after the mouse to remind yourself that all of the data in this should be related to this single mouse. Alright, we'll go. Now here we can see plugins on the left. This shows the pipeline. See the different UI elements. We'll start by clicking the Configure Pipeline button because we also want the concatenation plugin as per the processing that we did for the figures in the paper, and we want to put it here after GSR. But there you can see on the right it's popped up. Do note that it doesn't matter what order you do the processing in. So say you want to do cutoff and then GSR and then create regions of interests. You can do that with this. This is just saved automatically so that you can keep the plugins that you want to use nicely in order and in place for a particular project. So each project has its own unique pipeline. So we'll start with importing the data, of course. Since we're using raw videos that we captured from a Raspberry Cam, we have to specifically specify exactly what size the raw files are, how many channels this has, and its data type. So I'll quickly import 3 of those. How does it happen? Right. So what has just happened is we told it that this is first of all, these parameters are taken into account since we imported a raw, and the raw has no header, so it's important that we have this data. Then after that, it looks at the scale factor and the channel, and it sees it doesn't have to scale it down. So if this was 0.5, we would have ended up with a 128 by 128 import at the end. However, we're keeping it at full size. And this specifies which channel we want to import. So we can only import one at a time. If you want to do multi-channel analysis, you have to take the same file and import it twice. Okay? Okay, so this data over here for the raws, however, you don't have to worry about them at all if you're importing TIFF files or importing NumPy arrays, because those both have headers for the program to work with. So this is only applicable to raws. Also note, of course, that you don't want to be importing files that are too large for your memory. So this is a memory-intensive program because Python is an interpreted language, so do keep that in mind. There are, however, checks and balances to make sure that the application doesn't crash when you run out of memory. So, due to the method that we have with our head fixing technique, see Murphy et al. For that, 2016, that paper, you can see over here, if we double click, that at the beginning as a mouse is being head fixed, there's often some movement artifacts, right? You can see the blurring. And we found that if we just get rid of the first 20 frames across any trial, that tends to get rid of it all. So that's what I'm going to do. Why is the background keeps switching? So we can select all the videos on the right. So don't forget, you can imagine that there's 31 files listed here. If you were replicating the analysis exactly, we select 20, and then we cut off the frames, and then this is going to apply the cutoff to each and every single video file. And this generally works for every single plugin. You can select which files you want to apply the particular plugin processing step to, and you click a button and it is applied to it. Note that currently the abort button doesn't work. I'm well aware of this, and this will be fixed in a later release, not too long from this one. So as you can see here, finally the output files have been created. Double click this, and indeed the 20 frames have been cut off. Right. So the next, let's go to the alignment plugin. You can see now, after that, we now have a filter over here. If we click this, it filters it to only the cutoff. So the very last plugin processing step that was processed, we can filter by that. So in the alignment plugin, what we're trying to do is pick a single reference frame, and then everything is aligned to that one reference frame. So how do we select it in the plugin? As it is in its current incarnation, we pick a particular number of image stacks. So over here we'll pick 3. Over here we pick which frame we want to select from those image stacks. So for each of these we'll take the 400th frame, which is nicely in the middle. So, and as you get close, we start clicking the keyboard if you want to be very exact. So the 400th frame from each one. Okay? That's what this application is doing. This plugin is doing. What it then does is it takes the 3 frames from those that we've taken, and it averages them. So this is only a single frame, as you can see here, and this is the reference frame that is going to be used to align everything to. So we've taken the average from the 400th frame across all of the image stacks after cutoff, because we use the cutoff. So again, we can filter that through. You can see the reference frame stays there, and now we say we had 31 files in this. So we had 31 image stacks that was collected identically to the paper. What we would then do after computing the reference frame is select all 31, including this, and then click Align. And this is then going to align all image stacks and all the frames to your reference frame. So I would like to note that as this happens, that we can also spatially filter image stacks if we want to, for instance, emphasize blood vessels. I shall show you what plugin that is. Right, I've skipped ahead past the processing because it does take a bit of time, and the application is not usable until the processing is completed. So the application, the code for this application is not really well multi-threaded, so after you click processing you have to wait for it to finish or abort it. So as I was saying, I'll quickly show you the spatial filter. I'll add this to the end just to showcase it. So the spatial filter plugin allows you to, let's take the cutoff data, allows you to pick the size of a mean kernel, and then the image stacks are convolved with it, right? So a mean filter kernel convolved with it, and then that can be used to spatially filter every single frame in the image stacks that you select. So let's just pick this one, apply the filter, and then that can be used to, for instance, emphasize blood vessels. We have found by trial and error that a filter size of 8 is generally good for the mice that we use in the lab. I think it's the AI94s. And that kernel size nicely filters out so that it emphasizes the blood vessel. I'll show that as an example over here. So here, for instance, the reference frame, and then here's the spatial filter. See, this has been nicely blurred. Get rid of the smaller data or what might be recorded in noise, which in turn then emphasizes the blood vessels, which is used to align to. So you might be asking yourself now, okay, so we have the one method where you spatially filter out like this, and now say after you've created this spatial filter, what you can then do is go back to the alignment plugin, and then select only this is the spatial filter data, and then compute a reference frame, right? So over here now you can see we have 2 reference frames. Here is a reference frame made from the spatially filtered data, where we've taken the 400th frame from the data that's been spatially filtered. So now if we selected this spatially filtered data as as the reference frame and then selected all of the cutoffs, we would be aligning to something that's been spatially filtered. However,